Good afternoon. My name is Kevin Kovac, and today I'm going to be giving a little presentation on matter, life as we know it. Everything in the world in which we live in is made up of matter, whether that be a solid, a liquid, or a gas. And matter, defined by the dictionary, is the substance or substances of which any physical object consists of or is composed of. So when we look at the solid, that means that the molecules, which we'll go over between things, are densely packed together. When something's a liquid, it has a little bit more space and then you can compress it a little bit, but not too much. And then there's gas, which has the most space between them and you can compress, it is compressible. So these are the states of matter in which everything is made up in, again, either a solid, a liquid, or a gas. So let's dive into it a little bit more. Atoms are the smallest structure of life. Everything from elements to compounds are made up of atoms. And by the dictionary, the atoms are the smallest component of an element, having the chemical properties of the element, consisting of a nucleus, which is this here in the middle of the atomic diagram, containing combinations of neutrons and protons. And as you can tell, the neutrons are the grave, leaving a neutral charge, and then protons with the plus signs leave a positive charge in the middle of the atom, while electrons are bound to the nucleus by electrical attraction, meaning that they are floating around in these orbitals around the nucleus. Those are giving off negative charges. So molecules, defined by the dictionary, is the smallest physical unit of an element or compound, consisting of one or more like atoms in an element and two or more different atoms in a compound. So if we look at hydrogen oxide or water, we have two hydrogen atoms and then we have one oxygen atom. These two hydrogen atoms, they bind to the oxygen, forming a water molecule. And that, in itself, the earth is made up of a ton of water, and we need it as people every single day to be able to survive. So if we jump then from we go from molecules to, or we go from atoms to molecules, and then let's talk a little bit about elements. So elements is a class of substances that cannot be separated into simpler substances by chemical means. So here on the periodic table of elements, this is what the symbols would look like. Fe is iron. It has an atomic mass of 55.845, and its atomic number is 26. So it's 26 on the periodic table. And this is just an example of what it looks like. This iron can no longer be broken down any farther because it is pure iron. But a compound is a pure substance composed of two or more elements whose composition is constant. So for example, NaCl, sodium chloride, which is salt, the sodium has a plus charge, as an ionized in a plus, with one floating electron, one valence electron. And then the chloride has 7 valence electrons with a negative charge. And so it will attract that one positive charge to complete the outer shell of valence electrons to complete 8, forming, again, salt. And so with these compounds and everything else in the world, we start to have mixtures of things. And there are two kinds of mixtures. The first being a homogeneous mixture, which is a mixture in which the composition is the same throughout the entire mixture. So this Kool-Aid packet's a good example of that because it's the same through and through. There are no lumps or clumps in there. It's just, it went from water in a powder to a juice. Whereas the opposite is a heterogeneous mixture, which is a mixture in which the composition is not the same throughout. As you can tell, this chicken noodle soup is not what is known as a homogeneous mixture because you can see the individual carrots and celery, noodles and chicken, and the other greens inside of it.